Hi, this is Jackie, and today my final exam is about using Cuda parallel computing to quicksolve, and my professor is Lin Zhenghong. Okay, let's get it. And what is quicksolve? Quicksolve is you need to the first one you need to select the pivot, and quicksolve first select an element from the array as the best value called pivot, and there are many selection methods such as selecting the middle element, the first element, and the last element, or the random element. And in my case, I select the middle one. Yeah, so you can see the right side, the array, and they pick up the 6 as a pivot. Yeah, and the second step, you need to use the partitioning. The entire array is rearranged so that all elements smaller than the best value are placed on the one side of the best value, and element greater than the best value and placed on the other side. Once this step is complete, and the place value is in the final position. So you can see the right side image. They will pick up the one pivot, and then they will divide the tube side. One is smaller than the pivot, and the other one is more than the pivot. And the next step, you can see the recursive sorting. Quicksolve operations are performed on the subscription to the right and left of the benchmark value, which includes selecting the benchmark value, partitioning operations, and then recursing. This process is repeated until all the subscriptions are ordered. So you can see the right side the image. The final step, the 10 and the 15, is all these correct sort position. So they will again and again to do the divide these operations. So they can final make the quicksolve the array that every element can be sorting the right position. Yeah. And this image is called the Cuda parallel computing. You can see the left side. The left side is one CPU to one GPU, and then the GPU will return the value back to the CPU. But in my case, we use the CPU to convey their data to the GPU, and then the GPU can share their subtext to operate these tags. So you can see the GPU have the 4 tags, the 4 or 5 subtext to process this value or this data. And then these 5 tags can become the 4 tags to process the other value and other data. And then they will return back the value and the data, and that can make all the process more quickly. Yeah. And in my case, we write the first step is implement the 2 Cuda device function for quicksolve. We have the two function. The one function is the swap, and that can exchange the value of the 2 integers using point parameter. And the second one is you use the partition function, performs the partitioning step over the quicksolve by selecting the last element of the array as a pivot, and rearrange the array so that element less than or equal to the pivot are on the left side, or element greater than the pivot are on the right. And it returns the real partition index, indicating the correct position of the pivot in the array. So this function from the basic from implied mean the quicksolve. So you can see the right side we use the 2 function, and these 2 function we use the device keyword. Device keyword is we use to mark functions that are only available on the GPU, and this function cannot be called directly from the CPU. And the next we will use the global keyword. So I say the global keyword function, and This keyword is used to mark the kernel function, which can be called from the host to execute on the GPU, and kernel function must be confuted with the SNES to set out the execution parameter. And so as you can see, the swap is transferred to integer, and the partition is we use to set up the pivot, and we use to transfer and rearrange the array all the element. In my step 2, we can see we write a quicksort kernel, and this function we mark the global, and this function is implement the parallel quicksort using Cuda, and the quicksort kernel function is a GPU kernel function that partitions the array into the two parts and recursively sort length, and when the recursion depth is less than 16, it creates non-blocking Cuda scheme to parallelize the sorting of the left of the right part. And we also write the two function is quicksort and the print data. The quicksort function is called from the host to left the quicksort kernel and the signals GPU operation to ensure all computations are complete, and the print array function is print all the array content. And this code shows how to use the Cuda string and recursion depth control the obtains parallel computation. And third one is the lab step, and we write a main function, and this main function is mean how to use the Cuda for parallel quicksort and make sure its execution time. It starts by creating an array of 10,000 render integers, and then they can organize the memory on the GPU and transfer the array from the host to the device. Cuda even are set up to record the execution of the sorting operation. So this quicksort function is called to perform the sorting on the GPU, and the execution time is calculated and print. So finally we can see this sort array is transferred back to the host, and GPU memory is filled. The code afterly to use the Cuda and action the parallel computation. And in this main function, we write some Cuda syntax, like the Cuda event character. We use the Cuda event character to be my start time, and the Cuda event create stop to be my M time. And we also use the Cuda event record to record the execution time. And then you can see we also use the Cuda event since resize that can record the stop time or the M time. And that's we use the Cuda function sequence to record or create some parameter or record some execution time. So that's my last step. We use this Cuda function to make sure the execution time. And the last one is my performance. In my performance, we use the 10,000 element in this array, and in this array we can see the iterate and the execution time. In the first iterate, we can see my execution time is the 0.033896, and the second iterate execution time is 0.033628. You can see the first one is, you can see the third one is less than second one, and the last one is less than the first one. So if you iterate more time, you will get a more better execution time. So that's my introduce is about we use the Cuda partial computing to quicksort. Okay, that's my introduce. Thank you.